As we go further in this course, I have to get more in details. By now you know that you can pattern a feature either linearly or circularly, but you must know there are more types of pattern that are very useful in different situations. Like the one that allows you to fill an area or follow a non-linear, non-circular path. In this video, we are going to learn the so-called sketch-driven pattern that allows you to create multiplications of your feature or solid bodies on specific points that you predefine. But that's not all. Regardless of the pattern type you use, you always see a small option on the property managers of your pattern tools that is called geometry pattern. I'm gonna teach you when to use it, why to use it, and when not to use it. That's a small tip, but a very important one that can save you a lot of modeling time. So as I said, I'm gonna start off this video by telling you about the geometry pattern itself. Regardless of what feature pattern you would use, that is, whatever you find on the features tab over here, whether it's linear pattern, circular pattern, curve-driven, sketch-driven, or any of the other patterns, you will see an option over here down in the property manager called geometry pattern. And sometimes, depending on whether or not it's checked, you can or you cannot complete your pattern. Now, we're gonna go over this option and tell you how it works and when you have to check it, when you have to leave it empty. So over here, I have prepared a solid body for my example. It's a flat surface on 5 sides, 1, 2, 3, 4, 5, and the top one is curvy. So on the bottom, I have created a slot and cut it through the component using simple extruded cut. However, if I edit the extruded cut, press space on the keyboard, first edit, click here, space, and make it normal too, like this. I have changed the end condition on direction 1 from the default mode, which is on blind. We will go through all of these options later, don't worry, to offset from surface. That allows you to pick one reference surface, which I will use this one, and pick an offset value, which I've set it to 4. Whether it's millimeter or inches, doesn't matter. It means our sketch will be cut through the component and will be stopped with an offset value of 4 just before hitting the surface, and it would follow the format of the surface. You can see it like this. It's not flat anymore because putting it to blind, you will see the top portion of it is flat. But if we set it to offset from surface and pick it, put it to 4, you could see it would follow the format of the surface. Now we have this ready. In order to see it, I'm going to change the viewing style to view with hidden lines so you could see what happens inside the component. And now we're going to use a simple linear pattern to create instances of this cut in this direction. First thing first, you need a direction for the linear pattern, and I'm going to pick this straight edge on the side of the component, and then I would go to the features and faces, pick the inside surface of the cut to pick it like this. Now you can see that we have a couple of instances, 1, 2, 3, 4, 5, 6, 7, 8 instances of our original cut, and I'm gonna go down in the property manager of the linear pattern until I see these options over here. First thing first, change it from partial preview if it's checked to full preview. So we can see this is the full preview of our linear pattern. Each one of these instances are a little bit different. This one is the tallest, this one is the shortest, but they all have one thing in common, and that is they are following initial format I have defined for the first one. They are all offset with a value of 4 from this end surface. Now look what happens if I go ahead and check geometry pattern. Now they are not following the format. Instead, you are actually creating more instances of this initial geometry. Now you know what the main difference between checking and unchecking the geometry pattern is. However, this difference does not stop here. Let me uncheck it and click OK. We have one error, which is, okay, this value, I have to pick it and click OK. Now there is a tool, if you go to the Evaluate tab, that allows you to calculate the performance of your SolidWorks depending on the number and the type of features you have used in your design tree. If I go to the Evaluate tab, I will see this option called Performance Evaluation. This box allows you to know which of these features you have used takes the most amount of time in order to rebuild your model. Rebuilding means if I go back and edit this feature, and click OK, it will immediately be rebuilt. But if I go back and do this one, it takes a little bit longer, and that time is relative. It depends on how many features you have used. If I have 3, maybe the longest would take 1 second while the shortest 0.1. But if I have 300 features, maybe the longest would take minutes to rebuild, and you don't want that. Currently, in this model that I have not checked the geometry pattern for my linear pattern is taking 68% of the rebuilding time. Now let's just close this and go edit this feature by left clicking on it once and picking edit feature and check geometry pattern. Now let's see what happens. We were at 68%, now we are down to 50%. So it means the rebuilding will be much faster. So in cases like a flat surface on the top, if I go ahead actually and change my original drawing, delete this line, make a straight line instead, and cut these two, rebuild it, I have to change that again, pick this surface instead, value 4, let's just do it like this. Click OK. All right, change view. Now, instead of having a curvy surface on the top, I have a flat surface. So regardless if I check or uncheck the geometry pattern, the result will be the same. In this case, you always pick the geometry pattern checked because it will shorten the rebuilding time and it will increase your performance on your model. Okay, so far so good. Now we go to the second section of this video, which was the sketch driven pattern. For that, I have prepared a random logo that nobody knows, and on this logo we have created 2 extruded cut holes in the shape of hexagons. Now I'm gonna go ahead and use the sketch driven pattern to fill up this Nike logo and create a honeycomb out of it. So for that, I would go to the Features tab, pick Sketch Driven Pattern. First thing first, you would need to define the sketch, and we don't have any sketch, so I cannot use this feature yet. Let's close it, go back and talk about the sketch that I need to have. All you need to have is points. Wherever you place a point on a sketch driven pattern and pick a feature, that feature will appear on that point. So I'm gonna fill up this logo with a bunch of points with the right distance from each other to create a honeycomb. Let's see what I do. I'm gonna go ahead and draw on this top surface of the component and click sketch to activate the sketch mode, press spacebar and make it normal too, like that. Now, since the center of these hexagons are gonna be placed on top of these points, I'm gonna ahead use center line to help finding the center of these hexagons. I can now place the points on the midpoint of these hexagons like this and get rid of the center lines itself by pressing delete, and perfect. So I have done the calculations in the past. I know the distance between the horizontal values of these 2 points and the vertical ones, and I'm gonna go ahead to the sketch tab and pick linear sketch pattern to fill up this logo with these points. First thing first, I will go to entities to pattern and pick these 2 points because these 2 points are what I want to pattern. The direction 1 in the x-axis has to be 9.66, and in the y-axis activated by increasing the number of instances from 1 to 2, otherwise it's deactivated, to 16.73. So all I have to do is to increase the number of instances in both directions to make sure that the logo will be fallen fully onto these points. Too much, maybe that'll do. This side of the logo is still not covered, so I'm gonna move these points a little bit to the left and a little bit to the left and a little bit down. So let's just highlight them all, go to the sketch tab, go to move entities that we learned about and change it to XY. Now I can go back 9.66, maybe one more time, and go down one time, 16.73. There you go. I think that'll do. Why did I use these values? Because these values are the distances between the points. Now I still have 2 points in the center of my hexagons. If I did it randomly, the points might have been placed anywhere else and that would have not worked well. So I'm gonna go ahead and rebuild this. We can go to the Features tab now, pick Sketch Driven Pattern because we have our sketch ready. We will pick it, all the points. Now we need to pick our features, which I did, and click OK. Due to the high number of the features and the hexagons, it might take a little bit longer depending on your computer's processing power. Click OK because we have created multiple bodies, and hide these sketches. Now we have our honeycomb Nike logo, and we use sketch driven pattern to create that, which is one of the options. It's not the only option, but now you know how it works. In the next video, I'm going to go ahead and cover the curve driven pattern, which allows you to create multiple instances of your solid bodies or features following a non-linear or non-circular path.